Hi, good afternoon, and well, still morning, I guess. I wanted to say just a word to you before you watch the video of what the bleep do we know anyway. This will, for those of you who don't have any background in quantum mechanics, quantum physics, which is probably all of you, because quantum mechanics is a higher level physics course in in college and in graduate school, and for physics majors. It's not for the faint of heart. But quantum physics is something that came about. Actually, it began a little after the turn of the 20th century, back in the early 1900s. Probably the person who is you're most familiar with, who had anything to do with quantum mechanics is, and by the way, quantum mechanics and quantum physics is the same thing. Just some people, there's time you call it quantum mechanics, time you call it quantum physics. It's the same. But the person that you probably are more acquainted with that has anything to do with the beginnings of quantum mechanics is Albert Einstein. Of course, Einstein did a lot of work in what we now call relativity theory, that basically existence is relative to where we are in the universe, then there's a lot more that goes along with that, but there's no use. But basically, Einstein came up with this idea that everything is not exactly as it seems to be, that there are different levels of reality, different planes of reality, those kinds of things, that ended up being up to 12 of those. He didn't go into that, but it had been developed after that. So quantum mechanics has its root in that early beginning of Einstein, then went on to Niels Bohr and other physicists. And basically, now we have the ability to do things that were not able to do. There are two kinds of physics. Let me say there's two kinds of physics. There's Newtonian physics, which is what you're well acquainted with. Laws of electromagnetism, gravity, those kinds of laws that govern nature. You know, when you turn loose of a ball, it drops down, it doesn't go up. Why? Gravity. That's Newtonian physics. You learned about Newtonian physics in high school if you took physics. And everything is geared toward explaining how things work in the world. Natural law physics, you could basically say. Well, quantum mechanics, quantum physics is not that. It's a very specialized field in physics that came into its own, began coming into its own probably less than 50 years ago, and has developed since then. And basically, what we've been allowed to do because of technology is been allowed to go down further into the beginnings, into the rootage of things that are. Let me explain to you what I'm trying to say by using an illustration. It was at one time believed that the atom is, in fact, the word atomos, from the Greek atomos, which means smallest thing, was posited back in pre-Socratic Greece. A philosopher named Democritus came up with the idea that there are these little things floating about. You can't see them; they're too small. But they're floating about, and they join together in different hooks and ladders and things like that make things. Well, that wasn't far from wrong, and he had nothing to work with. But anyway, fast forward on to atomic physics, macroatomic physics that I'm talking about now. Basically, physics says atoms are the smallest thing. So things are created from atoms. Things are made from atoms. Atoms make molecules. Molecules loop together, make stuff of different kinds. And so this is the way the universe works. It's atomic universe. It's an atomic basis. Well, technology has allowed us in recent years to go down into atoms and see always knew that there were things in atoms. There were neutrons and protons and electrons, those kinds of things. But this allowed us to go down further to see things like quarks, things that are smaller than what we had previously thought were the smallest things. I said, let me use an illustration. If you look at it, the world through Newtonian physics, atomic theory, it says that I'm sitting here, I can pat myself on the head, I can feel that solidity. Actually, there's a bit of mushiness right up in here, but feel that solidity. And I can trust my eyes. I can see me here, see my wife there. I'd rather look at hers, look at me. But anyway, see our son there and our daughter-in-law there. I see our grandchild here. Anyway, so atomic physics says that this here is made out of atoms, it's solid. It's just solid. It's there. It's what it is. And the world is solid. And it's what it is. You don't have to wonder about it. Trees are trees. Bugs are bugs. Roaches are roaches. Grass is grass. This is just the way things are. Well, is that really true? I'm talking about now, I'm giving you this as a precursor to what you'll watch in the movie, What the Bleep Do We Know Anyway. Well, no, that is not altogether true or correct. What is an atom? An atom is, of course, a very small thing. And most of an atom, there are these little, excuse me, things called electrons, which are not really substances. They're not really mass, but they're energy waves. Energy waves. Now, can you see energy? No. Energy has taken my hand from here to there. But I could see my hand, but could I see the energy that took it from here? No, I couldn't. So these smallest things are actually not so much things that are physical as they are basically just real. In an atom, most of an atom is made up of empty space. Not a vacuum, but empty space. Space is something. So in this room, if this were an atom, then this is going to be too big. I can't find anything small laying around here. But the nucleus of an atom would be maybe something like that tip end of my finger sticking up there. That'd be the nucleus. Then there would be these wavy electrons that are floating around, circling around. And they're really not substantive. They are in some sort of energy wavelength. So the rest of it in this room, you got this, which is a bit of solidity, a bit of mass, and then you've got wavelength. But the rest of it is empty space. So most of this, even though it feels like it's solid, is empty space. If it's made up of atoms, which it is simply empty space. Now you say, well, it doesn't feel like empty space. But it is. It just is. I mean, all you got to do is just look through a microscope and see, and we can go down through atomic ideology and see that it is indeed empty space. So most of the world, most of the cosmos, most of reality, it's just empty space. And what is not empty space is most of it is simply wavelengths of energy. So what does this mean about my life and the things that I perceive? Well, it means it's not like we think it is. That solidity is not really solidity. But is it there? Yes, it's there. Is that table there? Is my head here? Yes, it's here, but it's not exactly as it appears to be. because I'm being, in some sense, fooled by the image or imagination that everything is as solid as I think it is, and it's not. It's just not. Well, I could go on for a long time talking about things like this, but as you begin to watch this movie, understand that premise, that what we experience, what we see in the world is, and I'll just go so far as to say, is basically not true. It's basically not what it appears to be. It's got to be something else. So quantum physics is a science, and it is a science. It's a very particular science, and a very complex and difficult thing to understand. But know that as you begin to watch the film, begin with that the world is not what you think it is. Now, that's not a bad thing. It's not craziness. It's not like ignorance. It's just the way it is. So let that be the beginning point if you're watching the movie, is that idea that, well, maybe I don't know everything. Maybe I've just not been schooled enough. Maybe if I were a quantum physicist, I would be looking at things differently than I look at them as just a normal human individual. Well, I'll stop there because that's really enough, and that's all I've got to say, really, to predicate the film without going into places that I don't want to go, because I'm not as good as an instructor as the movie is. That's why you're watching the movie. So good luck, and